Good morning. Can you all hear me?
Good morning. Thank you.
Yes.
All right. Thank you very much. I'll share my screen immediately.
Yeah, thank you.
All right. Yeah. Please, can you all see my screen?
Yes.
All
Yes,
right.
we can see.
All right. Thank you very much. My name is Caleb Onoja Kogu. Um, I'm from Nigeria, from the Department of Botany, GS Taka University, Makurdi, Benue State, Nigeria. I worked on effect of palm kernel and olive oils on the preservation of Casady Folly tomato, Solanum lycopersicum. Yeah, so Solanum lycopersicum, commonly called tomato, has great relevance in almost every Nigerian, continental, and global dishes. For instance, the vegetable is grown all around in Chill Island, that is Makurdi, Benue State, making it available and accessible and affordable. So we discovered that post-harvest loss is high due to mechanical injuries, microbial activities, and attack by animals, pest, among other factors. So we now decided that we should use natural preservatives such as palm kernel and olive oil that can easily be accessible by the farmers to prevent the loss of this tomato. So the essence of the research is to determine the ability of palm kernel oil and olive oil on the preservation of fresh Casady Folly tomato. Materials and methods. So we collected our tomato, we purchased it from Makurdi, Wadata Market in Makurdi, the capital of Benue State. And the oils we used for the experiment, we also purchased it from a supermarket in Wadata Market in Benue State. Treatment design, we got 20 tomato fruits. So we divided them into 4 groups, five tomatoes each. So the first group, we treated the first 5 tomato with palm kernel oil. Then the second group, we treated with 5 mils of olive oil. Then the third group, we treated with 2.5 mil of olive oil and 2.5 mil of palm kernel oil. So we mixed 2.5 mils of each of the oils. Then we treated the tomato with it. Then the fourth group was just control. It was left untreated. So what we did, we did measurement of physiochemical parameters. We observed the weight loss. So the weight percentage, Casady Folly fruit were weighed on electronic compact scale. So we first of all weighed this tomato and we're weighing it every day during the storage period. Firmness, this was estimated by hand assessment via a mathematical score scale of 1 to 5, where 1 is very poor, 2 is poor, 3 is acceptable, 4 is good, and 5 is excellent. Then the color, we evaluated the color daily using standard color chart as described by Dadza and Ocha. Then post-harvest decay percentage, the number of decaying Casady Folly fruits under storage were calculated daily by the formula GDP equals to number of fruits decaying all over total number of fruits times 100. Yes, for the shelf life, this was computed on basis of marketability and eating quality during storage period with appearance of the fruit as guiding factor. So for the shelf life, we watch the tomato daily to check the one that is still good, for that can still be eatable and can still be marketable. And also for the marketability, this was obtained using features such as number of physical wounds, level of shrinking, smoothness, and glossiness of fruit with the aid of a formula. And the formula was marketability of tomato fruit equal to total number of marketable fruit all over total number of fruit times 100. So we now evaluated some bacteria and fungi that aided the spoilage of the tomato during the storage period. So for evaluation of microbial quality, we had to first of all prepare our media. The medium used for the isolation and inoculation of organism, that is maconche, suboride, dextrose agar, nutrient agar, and peptone water, was prepared aseptically according to the producer's specification. So preparation of tomato concentration. So 1 gram of the most infected tomato from each sample, that is group 1 to 4, were cut and weighed. They were dissolved into respective corresponding volumes of sterile distilled water in the various test tubes. And inoculation of samples. After the preparation of our media, they were poured into sterile disposable petri dishes and spread by swelling, and then allowed to solidify. Then the media were inoculated with various dilutions of the affected parts of the tomato, and they were incubated for between 1 to 3 days for possible growth. Then isolation of bacteria. The incubated plates were removed and observed for microbial growth after 24 hours to 72 hours, and their colonies were counted. So subculture of bacteria, we also subculture the bacteria to get the actual bacteria we were looking for. So the solidified media were streaked with colonies obtained and incubated for 24 hours. Then identification of bacteria and fungi isolates. Both microscopic and macroscopic identification of these isolates were carried out to evaluate colony morphology. The gram stain technology was used to evaluate properties of bacterial colony and identify using biochemical tests. So at the end of everything, we now did the data analysis. The data collected were statistically analyzed using descriptive analysis and analysis of variance, using statistical package for social science, that is SPSS version 23.0, and mean separation was done using facial least significant difference. So for the result has tables. So for those that cannot be compressed, for this it was not able to be compressed as one slide. So I will explain, then I will go over to the table. So for the result, the weight percentage, we discovered that there was no significant difference in the weight in terms of the 3rd, the 5th, and the 7th day. The tomato was decreasing every day during the storage period, and the weight loss in the study ranged from 24.900 to 38.1400 during the storage period, and we discovered that the highest weight loss was observed on the 7th day, and the lowest weight loss was observed on the control on day 3. So the tomato were decreasing, the weight of the tomato were decreasing every day as the storage period progresses. And this is the effect of the weight loss. This is the table. You can see for weight before, because we did weight before, weight after 3 days, weight after 5 days, and weight after 7 days. So for the weight before, for palm kernel oil, this was the weight before, and for olive oil, this was the weight before. So we did the analysis for the weight before and weight after 3 days, weight after 7 days, and weight after the 8th day. Yes, and for the firmness, we also during the storage period we did the firmness test. So the effect of palm kernel and olive oils on the firmness of Casady Folly over the storage period showed that the main effect of the oils on the firmness of Casady Folly tomato fruit on firmness before and after the 2, 6, and 7 was not significantly different. Hence, there was decrease in firmness from the beginning to the end of the storage period. So we discovered that the firmness of the tomato were reducing every day as the storage period progresses. So the oil couldn't enable the tomato to be firm during the storage period. So for the parameters, these are the parameters. Then the scale, these are the scale. Then for palm kernel oil, olive oil, palm kernel plus olive oil, then control. So firmness after the 4, we discovered that it was for palm kernel oil, it was 0%. Then for firmness, the true firmness, we discovered that for palm kernel oil on the 2, there were 0%, as in 0 tomato were not firm on the 2. Then for olive oil, we discovered that 60% of the tomatoes were still fresh. So we did that for all the tomatoes as the storage period progresses to ascertain if the oil were able to keep the tomato firm during the storage period. Yes, for the color, we used the chart. The color was designed by Datza and Ocha. So we progressively check the color changes of tomato as the storage period progresses, and the modalities we used was pink, light red to red as the number of storage period increases. So for the parameters for color before, that is this. So we discovered that for palm kernel, we had pink as color before. Then on then the palm kernel oil, the tomatoes that were pink were 3. Then for CB after 3 days, for palm kernel oil, we discovered it was still pink and the number of tomatoes were still 3. So every day during the storage period, we were checking the tomato to know the color changes as the storage period progresses. Then for the post-harvest decay percentage, the post-harvest decay percentage of Casady Folly over the storage period showed that the post-harvest decay percentage of fruits increased as the storage period increased. Post-harvest decay percentage of Casady Folly showed that the treated fruits on day 8 showed the highest number of decays, which is 3, like 60%, and control showed the lowest, which is 2, 40% on day 8 after the treatment. So the tomato kept on decaying as the storage period increases. The oil couldn't preserve them. These are the treatment and these are the days. So for the 2, palm kernel oil had 0. That means all the fruits were still good. But on day 8, only 3%. That is 3 of the fruits were good. That is 60%. So as the storage period progresses, the oil couldn't stop the tomato from decaying. So there was no significant difference on the post-harvest decay percentage. Yes, for the shelf life of Casady Folly over the storage period showed that the shelf life of the fruit decreased as the storage period increased. So the shelf life of the tomato gradually decreased as the storage period increases, as shown in this table. Then the marketability, it also showed that the more the storage period increased, the more the decrease of number of marketable fruits. So marketability of Casady Folly tomato progressively decreased during the storage period, as shown in this table. They were reducing the market value of the tomato kept on reducing as the storage period increases. So for the microbial count, the effect of palm kernel and olive oil on the microbial count of Casady Folly over the storage period showed that the effect of the oil on bacteria, on McConkey agar and nutrient agar were significant, and the effect of the oils on the fungi on Saborai destruct agar media was not significant. That simply means that the oil were able to inhibit the growth of bacteria on the McConkey agar and nutrient agar, but the oil couldn't inhibit the growth of fungi on the Saborai destruct agar, and that's what that says. And on my microbial count on McConkey agar and nutrient agar, there was no significant difference in the growth of bacteria. That simply means the oil couldn't inhibit the growth of bacteria on McConkey and nutrient agar. Okay. When palm kernel and combination, that means for the combination of palm kernel and olive oil, the oil couldn't inhibit the growth of McConkey agar compared with olive oils with the controls. So in SDA media, there was no significant difference in the growth of fungi. So the oil was able to reduce the growth of fungi on bacteria on some media. However, it was unable to reduce the growth of bacteria on the other media. So in total, summarizing this microbial count, in general, the oil couldn't inhibit the growth of fungi and bacteria on the both nutrient media. So for the bacterial isolate, we're able to isolate some bacteria that were associated to the spoilage of Casady Folly tomato, and we isolated Klebsiella species, which has 5, the frequency is 5 and the percentage is 31.25. We also isolated Shigella species, Staphylococcus species, Escherichia coli and Salmonella species. So we used we were able to get these pictures with the aid of a microscope. So each media, we use a microscope to check their color. So these are the pictures of the bacteria that were associated with the spoilage of Casady Folly tomato fruits. Then for the fungi, we were also able to identify some fungi that were associated with the spoilage of Casady Folly. We isolated Klebsiella species, Shigella species, Salmonella species, Staphylococcus species, and this was a mistake. This was for the bacteria. I think I made a mistake. This was for the bacteria, but for the pictures, we have the Aspergillus species, Rhizopus species, and Mucus species. These were the fungi that we isolated that were associated with the spoilage of Casady Folly tomato. But for this table, I'm sorry, it was for bacteria. I was supposed to place the one of fungi here. So for the conclusion now, over the storage period, that is the 8 days in preserving this tomato using palm kernel and olive oil, we discovered that the oils they lack the potent preservative ability and may not be used as successful biopreservative and useful alternative to synthetic preservative. So the oil couldn't preserve the tomato, they couldn't extend the shelf life, they couldn't extend the firmness or marketability. The whole physiochemical parameters we used, the oil were unable to extend any of them. So we brought out some recommendations. We recommended that palm kernel and olive oil should not be used in the preservation of Casady Folly, and if they are to be used, the tomato should be sold or used as quickly as possible because the quality and the marketability of the fruit will definitely decrease over time. Thank you very much. So is there questions? Yes, we discussed.
But just to be like, okay, no questions. Then can I ask a question?
Yeah, please go on, please.
Yeah, actually, I am not from the botanical background. I am a surgeon, so but just to be like curious about tomatoes. Any reason to choose these tomatoes for the study? Specific reason?
Sorry, I didn't get that.
Any reason to choose this fruit for your study? You have chosen tomatoes.
Yes, we discovered that tomato was their major vegetable in Benue State, and it was planted all year. And the rate at which the post-harvest loss is high, so we discover how we can help farmers local farmers to preserve this vegetable. So that was why we selected tomato. Yes.
Do we have Zoya Arshad Awad from Pakistan? Can I request? Can I request Zoya Arshad Awad?